Hi guys, Mr. Bennett here. What we're going to do today is going to do question number 1 on page 52. So here we've got a car travelling around a bend of radius 50 metres where the road is flat and the speed is 50 kilometres per hour. Calculate the magnitude of the centripetal acceleration. So if we're going to go do that, let's write some stuff down that we do know. The radius is 50 metres. The speed or the velocity is 50 kilometres per hour. Alright, so you need to divide that by 3.6 right, to work out what the speed will be, and then that's the information that we do know. So we want to calculate the centripetal acceleration. Alright, so we know that force equals mass times by acceleration, don't we? And we only want the acceleration, so acceleration we know is also v squared on r. So in other words, to work this out, you simply have to go through and do your calculation of the velocity and square that and divide by the radius. I'm not going to do that for you, I think you can do that yourself. The next thing is talks about explaining the speed of the car remains constant even though there is an acceleration. Alright, so what's actually happening here is that it's going around a bend. Alright, speed can be exactly the same, so in other words the velocity changes as the direction changes, but the actual component of velocity is in fact the same. So the speed's changing, but the direction that the car's travelling is always continually changing, which means that there's a centripetal acceleration, and that's what you sort of need to explain there. You could, in fact, for part B, you could talk about the change in velocity equals the final velocity take the initial velocity, and obviously as it's going around the bend, right, you could talk about the initial velocity v0, and you could talk about the final velocity v. Alright, so obviously then that would be your minus v0, which means that it would be directed towards the centre of the bank itself. Alright, so if the mass of a car is in fact 1.3 tonne, what will be the frictional force required? Well, the frictional force will be equal to, for it to stay on the track, will be equal to the centripetal force. So again, I showed you the formula in the beginning. So force centripetal is equal to the force frictional. So you need to make a statement like that. I think it's important to do that. So therefore, the force friction as a subscript has to be equal to mass times by v squared on r. Alright, so the only thing you have to put in there is make sure that you put that into kilograms, 1,430 kilograms, and then you can times up by that by your AC, which you calculated in part A. So pretty simple question, just using banking of curves again, you know, looking at scenario. This one here, even though it's a banking your curves example, you're not really banking, it's just circular motion. Alright, so use the formulas that you need, don't sort of make it any harder than it has to be, and we'll do some more questions for you in the next video.